All right, so let's take a look at polar coordinates. Okay, we're going to separate this section into 2 days. We'll do half today, half tomorrow. Most of our sections we're going to split up, just to do them a little slower. All right. So this is the kind of grid that we've used for graphing. Okay, algebra 1, algebra 2, geometry, pretty much what you use. Okay, an XY axis. Okay, this kind of grid works great if you've got to graph things that are straight lines, but to graph things that are circular, okay, not the best grid. Okay, or things that spiral, okay, not that easy. All right, I'm going to take a look at a different way to graph, okay, and that's called polar. Okay, polar is very useful anytime you want to graph a circle. Okay, you want to graph things that spiral, you can do it very easily.
Was that previously?
Yeah, previously. Okay, and the idea with polar is instead of a grid that's run where the lines run up and down and left and right, okay, to create that XY axis pattern, you've got a circular grid. Okay, and what we'll do is we'll move out a certain number of rings, okay, from the origin or from the pole, and then we'll move a certain angle. Okay, and what I'll do is I'll show you a graph in rectangular, and then I'll show you the same thing in polar. And for the kind of graph I'm going to show you, it's going to be so much easier to do it in polar. Okay, I'm just going to type it in on the calculator.
Can you slide it up a little?
Slide it. Like that?
Yeah.
All right, so let's take a look at a graph. Okay, what I'm going to do is draw a picture of a circle. And you don't have to know how to draw it. My point in showing you this is how much easier it is to type in polar form versus using y equals. Okay, y equals is great. If you've got slope, y-intercept, y equals mx plus b, it's very easy to do on a grid, like you're used to. A circle, not so much. Okay, if you wanted to draw a circle, let's say I want a circle with a radius of 3. Okay, this is how I have to type it in. Okay, and I just want you to watch and see how messy this becomes. So it'll be 9 minus x squared, and that's only going to give me the top half of the circle. Then I need to put in something separate to get the bottom. Put in a negative. What that's going to do is take the top part, it's going to flip it over and make the bottom part. So second square root 9 minus x squared. Has anybody done a lot with graphing circles in algebra 2? Okay. So I just want you to look at how much stuff I have to type in. Not a lot, but enough. Now let's do zoom 5. Okay, and there's my 2 different colors. There's my circle with a radius of 3. All right. Now, I'm going to do the same thing in polar. It's going to all be one color, though. Okay, on my calculator, I'm going to go to polar. To graph a circle with a radius of 3. That's it. Zoom 5. And let's see what happened. I had something set for my last class. Let me just set it. There you go. It looks oval because the screen is wider than it is tall, so I can fix that by just changing my zoom. So there's my circle. All right. So my point is how much less stuff you have to type in, okay, to draw a circle like this versus rectangular. Right. Exact same picture. Now, if I wanted to draw lines on this, lines start to get pretty complicated in polar because you can't do y equals mx plus b. That's the other system. So I wouldn't recommend using polar to draw straight lines. I'd recommend it for circles. Okay, so every system has its advantages and disadvantages depending on what you have to draw. All right, so we're going to look at some more with polar. Actually, another kind of neat thing you can do in polar You can graph a spiral. Let me zoom out a little bit so you see it. Oh, you can kind of start to see it. But I could get a spiral. The more I zoom out, the more of it you'd see. Spiral would be pretty tough to do using XY axis stuff. Wouldn't be that easy. But very simple. That's it. That's the whole thing you type in to do a spiral. Okay, so with polar coordinates, you might have noticed it used the theta here. Okay. Normally when you're in rectangular mode, when you press that button, you get an x, because it's using xy coordinates. Well, polar uses theta. Okay? It uses an angle. So r stands for a radius. Okay? It's a distance from the origin. And theta is an angle. This is what a coordinate looks like in polar. R comma theta. So here's an example. That point says move out 3 units from the origin and then go 25 degrees. What we have to figure out is which way do we move? 3 units left or right? And then do we go 25 degrees clockwise or counterclockwise?
Does it matter if it's a circle?
Well, if you went 25 degrees clockwise versus 25 degrees counterclockwise, you could be in 2 different spots.
Why?
Well, think about if you were on the circle and I said go 25 degrees up versus 25 degrees down.
I thought that was just like...
You see what I mean?
I thought you were making like the circle was like...
Yeah, I'll show you. In fact, we're going to start out, we're not even going to graph a circle. We're just going to graph points. Just like you learned back in like pre-algebra, how do you draw a point? That's what we're going to start with. Okay, so the first thing you do is from the pole, move out the number of rings indicated by R. Now there's 2 different directions you can move. Just like on the X, when you had X and Y axis, you could either move left or you could move right. Well, whether you move left or right, it just depends on if R is positive or negative. Okay. If R is positive, okay, if R is greater than 0, you start from the pole and you move right. Just like on the x-axis. Positive value, you move right. If R is negative, okay, if it's less than 0, what direction do you think you'd move in that case? The other direction, left. Right, so if I was graphing the point 325 degrees, I'd have my graph paper set up. And again, it would have a bunch of concentric circles on it. And I'd start by going 3 units to the right. And I'd start right there. Okay, next thing I have to do is figure out, do I go clockwise or counterclockwise? All right. All you got to do is look at theta and see if it's positive or negative. Okay, so from where you just moved in step 1, if theta is positive, you go counterclockwise. How much? Well, whatever theta is. If it's 25 degrees, you go 25. If it's 90, you go 90. Okay, most of the points I have you draw are going to be nice angles, like 90, 45, things like that. Now, we can measure an angle in 2 different units. Charles, what's one unit you can use to measure an angle?
Degrees.
Degrees? Yep. And Ryan, what's another unit to measure an angle in? Radians, yeah. So my advice is if they give you something in radians, change it to degrees. If you like degrees better, I would change it. All right. So if you've got a positive angle, you're going to go counterclockwise. If you have a negative angle, okay, something less than 0, it's clockwise. If we need to write those down again after this, I'm going to abbreviate them CCW for counterclockwise and CW for clockwise. Okay, so any question on which direction R tells you to move in or theta? It's important when you start moving theta, it's from where you ended up in step 1. Just like when you graph XY coordinates. You go 2 units right, and then from that point, 3 units up. Okay? So 2 units right, and then from where you moved from the X value, up 3. Okay? So same idea. All right, so what I can do, if people want, I can print some of these out. So in your homework, you'd already have it. All right, the first one they want us to draw is 3, 120. Okay, Mariah, which way do I go for the radius? I'm going to go 3 units which way?
Counterclockwise.
Well, counterclockwise and clockwise, that's going to be for the angle. But for the radius, it's either left or right. To the right. Why not left? What tells you this is right?
It's positive.
It's positive. Perfect. Okay, so we're going to go 3 units to the right. Okay, so we're going to start right here. Okay, and now Katie, from this point, where do I go?
Counterclockwise.
Yeah, 120 degrees counterclockwise. I'm going to end up right there. Okay, the reason I was able to do that so quick, each one of these is 30 degrees. Nope, 15. I think they're all 15. So 15, 30, 45, 60. Yeah. Okay, so I went 90, that'd be straight up, and then I went 30 more to get to 120. And that's it. That's how you graph a point and polar. So right 3. Counterclockwise, 120 degrees. Any question on that? We're going to try all different ones. Try some with degrees and radians, some negatives, some positives, all kinds of things. Okay, 5 comma pi over 4.
Is this one that we're going to have worksheets with?
This one will be in the book. Yeah, this one will be in the
Do we
book.
like draw anything?
You will have to draw points, yes.
No, like, will you have sheets for us with like this?
Yeah, I can get some graph paper, yeah.
Wait, can you go back to the one you said?
No, you don't have to draw the graph. You get somebody else.
Right. That was just an example, right?
That's just an example, yeah. We're going to do like 7 or 8 of these, just graphing a point. Okay, let's look at the next one. What could I do first here?
Switch it.
Yeah, what would you switch it to?
Degrees.
Degrees.
Is that where you can be?
So pi over 4. What is pi over 4 in degrees? 45. Yeah. Does everyone remember how to change to degrees if you have to?
180 is on top,
Yep.
and then just
Divide by 4. Yep. So just 180 divided by 4. All right. So now we'll start with the 5. Okay, so Holly, this tells me to go out 5 units. Which way? 5 units right. Now from this point, we have to move 45 degrees. Our choices are clockwise or counterclockwise. Jacob.
Counterclockwise,
Yep. What tells you counterclockwise?
it's positive.
Positive. There's the point. So 5 units right, 45 degrees counterclockwise. Okay, any question on that? When I have you graph something, I'm never going to give you probably any bigger than 5 or 6 on the radius. So if you have to, you could draw 5 or 6 circles. You could also go by 2s. That's fine. You can go in between circles if you have to. Okay, if it said 1.5 units, you go out 1.5 units. Okay. Okay, 5, negative 210. Okay, Chelsea, which way am I going to go this time? 5 units?
Right.
to the right. And then how about the negative 210?
Clockwise?
Yeah. So we're going to start here. And then we're going to go 210 degrees clockwise. All right, if I go halfway around, Brittany, how much is that?
180.
That's 180. How much more do I need to go? So we're at 180. What's the difference between 180 and 210? 30. So we got to go 30 more. Okay, so we started here. Halfway around is 180. If you go 30 more, that brings you to negative 210. Okay. Any question on that one? Usually, once you draw it, you can't tell which way the person went to get there, unless I did something like that. Now you can tell. Okay, on the test, you don't have to show me how you got to the point. Okay, I'm just going to look and see if you put the point in the right spot. Let's try this one. Okay, first thing I'd do is try to change radians to degrees. How much is that? Yeah, that's 90. And this is the first time we've had a negative radius. Right. So Danielle, which way am I going to go from the pole or the origin? Same thing. 3 units which way? To the left. And now from this spot, we're going to go 90 degrees. Which way, Casey? Are you going to go clockwise or counterclockwise? Counterclockwise. Okay, so counterclockwise, that's that direction. So from where we moved in step 1, oops, 90 degrees. Counterclockwise. Bless you. Any question on that? So we went left, and then counterclockwise. Some people get confused with the negative. So 90 isn't always at the top. Depends. If you move left, okay, and you have to go clockwise or counterclockwise, you're starting from that point right there. All right? What's another way you could get to that point? Besides negative 3, 90. Yep. That's another way.
So all the way around 3, 270.
So that's 3, negative 90. Same spot.
3,
What?
270.
Okay. So we could do 3 and then 270. That would be 3.
Negative
270.
3, negative 270.
Negative 3 and then which one?
Negative 270.
So that's negative 3 and then clockwise 270. So how many ways are there to get to each point? 4 basic ways. You can go left or right to start. Then you can go clockwise or counterclockwise. Now, how about when you do x, y coordinates? If I wanted you to get to this point, is there any other way I could write that and have you get to the same point? Could I write like negative 2, 3, and that would come out the same? No. Okay, so when you're doing rectangular coordinates, there's only one way to write where you want someone to go. In polar, you can do it many ways. Okay, doing something like this doesn't count as a different way. If you go around multiple times, that's a repeat. Okay? Your 4 choices are you either go right, and then counterclockwise, right, clockwise, or left, clockwise or counterclockwise. Skipping and going around 3 or 4 revolutions, that's a repeat. Okay, any question on that?
No question.
Yep.
What's the thing to go from radians to degrees?
From a radian to a degree?
Yeah.
So it's 2 steps. Okay, if you have a radian like pi over 4, you multiply by 180.
It's just 180 over pi, right?
Yep. So 180 on the top, pi on the bottom. So it'd be just like this. Yep. Okay. Any question on that 4 ways to get to the same point? Okay, later on, we're going to do a question where I give you a point, and I'm going to ask you to write it 4 different ways. Okay, I might say do it with a positive radius and a negative angle, or a negative radius and a negative angle, but you can do it. Easiest way is to draw it. Rather than try to think it through in your head, visualize it on paper. All right, we already graphed one, but let's try another one of these. Okay, negative radius, negative angle. Okay, Jimmy, which way do I go for -2? I go left or right?
To the left.
Yep, we're going to go left 2. And then -180, Rosa, is that clockwise or counterclockwise?
Clockwise.
Yep, clockwise. End up right there. Negative left 2, clockwise 180. What would happen if you went counterclockwise? It would be the same thing. Whichever way you go halfway around with 180, you get the same answer. That's the only one that, if you mess up the direction, you'd still be okay. Every other angle other than 180, if you mess up the direction, you get to a different spot. 180 comes out the same, positive or negative. Okay. How about that one? 0, 300.
Nothing.
Where would it be?
Right in the middle.
Yeah, right in the middle. Okay, what's basically happening is it's just spinning in place. So when you draw it, make sure you put your pencil down and just spin it 300 degrees like that. I'm going to look for that.
Oh, yeah? Study that one?
Like, see the pencil?
Yeah, I'm going to look for the pencil spin.
It's got a special
Alright.
thing.
Right up the-
So anytime that your radius is 0, it just stays right at the origin. Okay, it doesn't move. Okay, what about if we switch it, okay, and make the angle 0? Will that stay at the origin?
Yeah, you just move to the right one.
So is it still at the origin though?
No.
No. If your angle is 0, you're always restricted to moving which way? Left or right? Left or right, that's it. In this case, right 1. Okay, so we've looked at every combination you could have between positive, negative, and 0. Any question on graphing a point in polar? That's it.
I'm so okay. Don't worry.
All right. So here I'm giving you a point, and I'd like you to try to write it 3 different ways. So the first way I want to do it is I want R to be positive, and I want to get an angle between 360 and 720. Okay, we haven't done this today, but we've done it before. Something you can add to an angle to make it, bless you,
Thanks.
make it bigger,
Yeah.
but it doesn't change. Okay, what can you add to an angle to make it bigger?
Itself.
360. Okay, if you add 360, it makes it bigger, and you land back at the same spot.
How does it make the angle bigger? It's just still in the same spot.
For example, these are the same angle,
Yeah, but,
but this one's bigger.
alright.
It's just a bigger number, but you're just going around an extra time to get to the same spot. All right. How about second way? You want a negative radius and an angle between 0 and 360. And then the third way, positive radius, negative angle. So I think to try to do that in your head can be kind of hard to visualize where it is, so we'll sketch it. First thing I'd like to do is, let's get rid of the radians. What's pi over 6? If you change that to degrees.
30.
30. Yeah, it's 180 divided by 6. Right, so what I'll do is I'll sketch it and see if we can figure out all these different ways. So I'm right there. Okay, I went right 3, and then 30 degrees counterclockwise. Now, I only have 2 choices for what R can be, for every one of these. Okay, R has to be one of what 2 numbers all the time? -3 or 3. If it's not -3 or 3, you're not going to land on the 3rd ring. Okay? There's no way I could make R 4 and land on the 3rd ring. I don't care what you make the angle. So R is either 3 or -3. So for number 1, what's R? 3. It said I want R to be positive. Your only choice, if you want to land on the 3rd ring, is to make it 3. Now, we just want to make the angle bigger.
390.
Right? It'd be 90?
390.
390. Yeah, 390. Just want to see how we got that. 390. So we go like this. Just going around one extra time. Okay, next one. They want R to be negative. So what would R have to be this time?
Negative.
It's got to be -3. All right. You know what? Let me get rid of that so it doesn't get too confusing. So we're going to go left 3. So start from there. And now we need to go in a positive direction, so counterclockwise. How many degrees would this be? Well, is it more than halfway around or less? It's more. So it's more than 180. It's 210. Yep. So you go halfway around and then 15, 30 more. So 210.
I got lost a little bit.
On this one?
Yeah.
So we went left 3.
Yeah.
Okay. And then somehow I got to get from there to there along that arrow. So each one of these lines is 15 degrees.
Okay.
So that's halfway is 180. 15 more, that's 30 and 180. So it brings you to 210. And Zach, how about my radius for the last one?
3.
Yep. This time they want +3. So start.
So the point is just to get back to there.
You got to get back to this point somehow. And now they want you to go negative angle. So they want you to go around this way. So we got to figure out, tracing that blue path, how big of an angle that is. -330. Yep. Again, I think it's easier to visualize it on paper. I have trouble trying to do that in my head. I just draw it, I look at it, and then I can just count the grid lines. Halfway around is 180. Or I just look at this section right here. That section is 30. 360 would be all the way around. So 360 minus 30. There's your 330. Okay. Any question on that?
Are those like the formula for that?
Is there a formula for it?
Are those like what you need to use every time?
Oh, in terms of the angle? No, they could. I don't think I did a negative angle and a negative radius. We did a positive, negative, negative, positive, positive, positive. I left one off. We could have done a negative, negative. So there's one more. We did that one. On this one. On this one, we did all 4. All right, so last thing we'll look at is how can we take a point that's in polar, okay, this new system, and change it back to rectangular. Because sometimes rectangular is easier, okay, depending on what you have to draw. Okay, so in polar, those are the two things you would have. This point has a radius, which would be from here to there. Okay, that's r. And it has an angle. That would be your angle right there. Any thought what shape I can use here
Triangle.
to maybe figure this out? Yeah?
Triangle.
Yeah, I'm going to make a triangle. Okay, I'm going to make a triangle just by adding in a third side. JC, what would be a good name for this bottom side? Think about what axis it's on. It's on x. And the height? Y. So our goal is to turn r theta into xy. That's the goal. And you'll be given r and you'll be given theta. Those will be numbers. All right, so if you knew r and you knew theta, and you wanted to find x, which trig function could you use?
Sine and cosine.
Well, in terms of, so like sine, cosine, or tangent. And if you're not sure, figure out the names of these sides. This one's across, r is across from the 90. X is right next to theta. Cosine. X is adjacent. R is a hypotenuse. If you think of it that way, R is a hypotenuse in a right triangle. So cosine. So cosine theta would equal, what side did I just say was adjacent to theta? X. What's the hypotenuse? R. Our last step is to get x by itself. So Christine, how would I move r to the other side?
Multiply.
Yep. Multiply by r. Those cancel out. And get a formula for x. So if you've got a polar coordinate, you know r and you know theta, and you want to know what the x value would be in rectangular, fill r and theta in, use your calculator, and you'll get x. Okay, now we'll do the same for y. Still would know r, you'd know theta, now we want y. Okay, Damiana, what trig function would do that? Would give me y? Yeah, use sine. So sine is opposite over hypotenuse. Carlos, what side is opposite theta?
Y.
Y. And what's the hypotenuse still?
R.
R. I'm going to do the same thing. I'm going to get get y by itself again. And we get another formula. So if you know r and theta and you want to find what the y value would be in rectangular, take the sine of your angle, multiply by your radius. That's y. And then when you're done, you'd write it as a coordinate. Whatever x is, comma, y. Okay, so those are your two formulas you need to change polar to rectangular. Same two formulas. Okay, so if you're given a point in polar, again, you're going to know r and theta. Use the following formulas to change to rectangular. Any question on those formulas? All right. You don't have to go through the proof each time like we did. You don't have to draw the sketch or anything. If you forget the formulas, you could do the sketch. Maybe that would help you remember them. Since you can make a reference sheet, you shouldn't be forgetting the formulas. Okay. I would definitely put those on a reference sheet. Whether you want to use degrees or radians, that's up to you. Okay, for this kind of problem, since I need to type it into a formula, I would change the mode on my calculator. The reason? If I mess up changing pi over 6 to degrees and use that messed up value, it's going to come out wrong. Just let the calculator do it in radians. Don't worry about it. All First thing we got to figure out is which one's r and which one's theta. That's important. Helene, which one is r here? 6. And then theta? Pi over 6. Now we'll just fill them in to find x and y. Okay, let's start with x. Chris, can you give me my formula to find x? Just fill in our numbers where they need to go.
6 cosine pi over 6.
Good. 6 cosine pi over 6. Now we'll do it in a second. Let's get y. Get the formula for that. Mariah, what's my formula for y?
R sine
Yeah, and what's r in this case?
6
Good. 6 sine pi over 6. Type it in and you're done. Let's see what we got. So x is 6 cosine pi over 6. If I'm going to type it in the way I have it written, what's the first thing I need to do?
Convert to radians.
Well, it's already in radians. Change the mode, yeah, my calculator to what? Perfect. Change your mode to radians.
That's what I just did.
Yeah. Well, I thought you said convert to radians. Okay, so now we got the right mode. 6 cosine pi over 6 comes out, it's 5.20. That's x. Many times, depending on the value, the answer doesn't come out nice. And y? 6 sine pi over 6. That one comes out nice. We get 3. Okay, so now write your coordinate. 3. Oops. X, comma, y. So graphing 6 comma pi over 6 or graphing 5.2 comma 3. They should be exactly the same thing. Okay, any questions on how we got that? All right, so what I'm going to do, I'm going to try to graph that. Okay, first I'm going to graph it in polar. 6 comma, that's 30 degrees. So I go right 6, 6, up 30 degrees. Okay, any question on how I graph that? Now, I'm going to take a rectangular grid. I'm going to drop it right on top of that one. And if we did everything right, it should look like it's a little bit more than 5 units right and exactly 3 units up. Let's take our grid. Okay, I have to use a grid that's the same scale. I think it's this one. All right, so does that look like it's 5.2 units right and then 3 up? Pretty close? All right, so there's our same point in rectangular. And then back to polar. So since it looks pretty good, I'm pretty sure we did that one right. So right 5.2, up 3. Any question on that? All right, so why don't you guys try that one on your own, and then we'll go over it, and then that'll be it. All right, so anytime you're going to convert from polar to rectangular, you need 2 formulas. Okay, one for x, one for y. Anybody think they can tell me, you don't have to give me the final answer, just what's my formula for x? Jordan?
R cosine theta.
Okay, so in this case, can you fill in r and theta for me?
-4 cosine 120.
Good. -4 cosine 120. And somebody else give me my formula for y.
-4 sine 120.
Good. -4 sine 120. Okay, anybody figure out the decimal for what x comes out to? You got 2? If you take your cosine of 120, you're going to get negative a half. Negative a half times a negative 4. Negative times negative is positive. Half of 4. 2. Okay, I don't think the decimal for sine is going to come out quite as nice. What does sine come out to? Negative 3.46. Okay, just to show anyone's not sure how she got it. That's the sine of 120. Now multiply it by negative 4. Negative 3.46. When you write your final answer, just make sure you write it as a coordinate. All right, so the homework tonight's on 308. It's all even. Don't do any odds. 12 to 26 and 40 to 46. Okay, if you do need graph paper, I'll print some out. I'll have it by 12:30.